Assalamu alaikum, Bismillahirrahmanirrahim. I'll be reading Quantum Mechanics Theory and Experiment by Mark Beck. This book was introduced to me by Dr. Sabi Anwar as part of second year undergraduate course at LUMS. I hope we have a wonderful time together. Chapter 1, Mathematical Preliminaries. Before beginning a discussion of quantum mechanics, it is useful to review some topics from mathematics and classical physics. In this chapter, we'll go over some areas of probability theory and linear algebra that we'll find useful later. You may be familiar with the concepts presented here, but I suggest that you read through this chapter if only to familiarize yourself with the notation and terminology we'll be using. 1.1 Probability and Statistics. 1.1.1 Moments of measured data. We want to measure a quantity x, which is a property of some object. So we break out our x meter and make measurements getting n values of x, xm1, xm2, etc. We are using the subscript m here to indicate that these are measured values. Collectively, we refer to these measurements as xmi, where I is equal to 1 to n. So basically it means that if we want to measure the quantity x, we'll measure it n times to get the average value. We can calculate the average x, triangular bracket x denotes average value of x, by adding up the measured values and dividing by the number of the measurements. So we can get the mean by adding up the measured values and dividing it by the total number of measurements that we made. To get the average value of x, we will add up all the values from I is equal to 1 to n, which means xm1 plus xm2 plus xm3 plus xm4 and so on till xmn, and divided by n, which is the total number of the measurements that we made. We'll use the bracket symbol to denote an average. It represents the average of whatever is inside the brackets. We'll also refer to average of x as mean of x. We can calculate average of xn by simply using the definition of the average. To get the average value of x of n, we need to sum from I is equal to 1 to capital N, bracket xmi to the power of small n, divided by total number of measurements, that is capital N. What this means is that we will add xm1 to the power of n plus xm2 to the power of n and so on till xm capital N to the power of small n, and add all of this up and divide it by the total number of measurements, that is capital N. Like this, we get average value of x of n. Another name for average xn, nth order moment of x. Remember, the brackets, triangular brackets, mean that we average whatever quantity is inside the brackets. We calculate this average by adding up the values and dividing by the number of measurements. The average of a function of x, f of x, is thus the average of f of x is equal to the sum from I is equal to 1 to n of the function of x mi divided by the total number of measurements, that is capital N. This means we will add fxm1 plus fxm2 so on up till fxm capital N, and then divide by the total number of measurements, that is capital N. The average is linear. This means that the mean of a1 f1x plus a2 f2x is equal to a1 mean of f1 of x plus a2 mean of f2 of x, where a1 and a2 are constants. Frequently, we are interested in how far a typical measured value might be from the mean value. Let's define the deviation from the mean as delta x is equal to x minus mean of x. The average of this quantity is 0, so it is not a good measure of the fluctuations. If we find the mean of delta x, then this means that we will take the mean of x minus mean of x, which is equal to mean of x minus mean of x. Since mean and mean of x is equal to mean of x, we get mean of x minus mean of x is equal to 0. Here we have used both the linearity property and the fact that once a quantity has been averaged, it becomes a constant. The average of a constant is a constant. Mean of delta x is not a good measure of the fluctuation because roughly half the time it's positive and half the time it's negative, so it averages to 0. To overcome this problem, we can average the square of delta x. Calculating this, we see that if we have to find the mean of delta x square, we would find the mean of x minus mean of x whole square. If we open the parenthesis of x minus mean of x whole square, we would get mean of x square minus 2x mean of x plus mean of x whole square. And if we open the parenthesis of the triangular parenthesis of the mean, we would get mean of x square plus mean of minus 2 mean of x times x plus mean of x whole square. If we open the parenthesis again, we find that the mean of a mean is actually a mean. So we would get mean of x square minus 2 mean of x times mean of x plus mean of x whole square. If we see this minus 2 mean of x times x is equal to minus 2 mean of x whole square, and we subtract it from plus mean of x square, we would get minus x mean of x whole square. So delta x square is equal to mean of x square minus mean of x whole square. The variance of x delta x square is defined as delta x square is equal to mean of delta x square is equal to mean of x square minus mean of x whole square. The standard deviation of x delta x is the square root of the variance. Delta x is equal to under root delta x whole square is equal to under root of mean of x square minus mean of x whole square. The standard deviation is a measure of how far a particular measurement is likely to be from the mean, and we will use it to quantify the uncertainty in the series of measurements. Thank you for watching. Allah Hafiz.